at the security aspect. So you have already heard about various other aspects of online social network security from Shomik and from Niloy. And I'm going to focus on some basic security attacks, security defenses against, firstly, broadly against machine learning systems. And then on Friday, we are going to look into some specific kinds of attacks and defenses against online social networks. I want this class to be interactive. Of course, everybody says that. I do mean it. So as a result, I'm going to have these Moodle pop quiz questions peppered throughout the lecture. They are not graded. They're just for fun, just for us to understand how things are going. And I will have a few informal questions for you as we are going along as well. So let me start off with one of these informal questions. So in this area of security or of machine learning, are there any particular algorithms that you have come across that you have found particularly insightful, particularly valuable in your work, and so on? So this is a question for anyone. And when you answer, please turn on your video and then volunteer your answer. So the question is, any algorithm that you feel you have really benefited from, that you have used a lot in your work, in your studies? So we'll have a fairly quiet and boring class if nobody speaks up during the class. So please step up. This is not a hard question. Hi, Shubham.
Hi, to me, as far as I have worked, I found that the specific graph algorithm of DFS has been good useful piece of algorithm for me. The reason being that I had to do a bit of scraping in my projects, like let's say link scraping and stuff, and sometimes like there's another project that I worked on which included HTTPS certificate scraping, and for that I needed to follow a lot of links, and in that area actually the DFS kind of algorithm, DFS kind of algorithm really helped. So
very good. My answer. And DFS is depth first search.
Yes, sir.
Very good. Anybody else have any input to contribute? Okay, so now let me launch into the first part, which is laying out some of the basics of security. And we'll go from there. Okay, Shomik, can you confirm that you're able to see my slide deck, which says Lecture 5, Security in Big Data?
It is there.
Okay, very good. Okay, as Shomik mentioned, I'm a faculty member at Purdue University in the EC and the CS departments. And we're going to talk about, firstly, some of the basics of security in big data. And then we're going to look at some more advanced topics in this. So let's start off from the very basics. So what do we mean by big data? So according to the US National Institute of Standards and Technology, NIST, which sort of provides fundamental definitions of various terms, lays out standards which are very widely used in the US and elsewhere. Big data is characterized by three characteristics: the volume, the velocity, and the variety of data. So it's volume is the obvious one. So you have large amounts of data. Velocity means that this is not just data at rest, but data in motion as well. In other words, data is being sent from one place to another, being generated in one place, being consumed at another place. And variety means there is heterogeneous kinds of data. So you may have data coming from social networks relevant to our class. You may have data which is coming from structured databases. You may have data which is coming from sensors which are deployed in the physical environment. You may have data which is coming from the watch that I'm wearing, which is measuring heart rate, and the more fancy watches even measuring SpO2 or EKG. So different kinds of data are coming together, and you're trying to gather certain insights from all these different kinds of data that are coming together. So big data is characterized by the volume, the velocity, and the variety. And to support all of this, you need a scalable architecture for efficiently storing all this data, for efficiently manipulating all this data, and obviously for analyzing all of this data. So now in a little more concrete terms, additional characteristics that most big data environments have are just in terms of volume. You can think of a petabyte or more. It has distributed and redundant data storage so that you don't suffer from a failure of just a single point going down and bringing down your overall environment. It can leverage parallel task processing, meaning you can have multiple processors or multiple threads in parallel working on the data, and it can provide data processing capabilities. So you may have encountered MapReduce or SPARC, which are two very popular platforms which are used for data processing in big data environments. You should be able to ingest data very quickly, so very fast data insertion. And typically there is a centralized management of the data. It is often hardware agnostic, so you don't care whether your data is running on an Intel processor, your data analytics is running on an Intel processor or an AMD processor. You don't care whether your data is being stored on a Seagate drive or on a Dell drive. And this is more from the software side. The software capabilities can be fairly easily composed and augmented. So there is a composable building blocks that are used, so that maybe one part of the building block is a classification algorithm. The next part of the building block, the next building block is an anomaly detection algorithm. You are able to fairly easily mix and match these different building blocks in order to create different capabilities. So by the way, during the presentation discussion, I really want this to be a discussion. So please chime in with any questions, any comments that you have. You don't have to wait for me to give a break at a certain time of the lecture. And the lecture, of course, is all of 2 hours, and none of us have the capability of concentrating for all of 2 hours. So I'm going to give breaks in between. So every 40-45 minutes or so, I'm going to have a break of 5 to 8 minutes. So, and then we'll come back. Any question based on this?
No, sir. No, sir.
Okay, so moving on. So what are the security challenges in big data? So you've all come across various security mechanisms which are used in computing systems. Are there any special kinds of security challenges as they exist in big data systems? So there are new security challenges which arise not just because of the amount of data or because of the velocity of data, but if you think of security in more traditional computing systems, now I'm generalizing this quite widely. The data often lies in silos. Does anyone know what silos means?
Containers, cylindrical containers.
Containers, and these are not connected. So a data may lie in an IIT KGP computer science silo, and another piece of data may lie in the electronics department silo, and another piece of data may lie in Purdue computer science, And there is no easy way of connecting the data across these different silos. The data is static, so it is not in motion. It's stored in one place. You're not doing analysis on the data as the data is moving. So this is called streaming analytics. You're not doing that. And this goes in with the silos. The data is firewalled in semi-isolated networks and enterprises, and there is no desire to obtain value from the data by connecting data across these silos. But when you use big data systems, then the data parallel computing frameworks like SPARC enable the aggregation of data from various different places. And with the aggregation comes the danger that now a lot of your data is sitting at one place. So every other day you hear of data breaches at credit card companies, at finance companies, at computer social network companies. And that is because the data has been aggregated from various different sources and is sitting at one place. So every time you hear about yet another Facebook data breach, yet another Twitter data breach, yet another Capital One, Bank of America data breach. Fundamentally, at its heart, it's because all these data parallel computing frameworks are looking at ingesting data from one place, doing its analysis, and writing out the analysis results also in one place. Well, they're ingesting data from various places, but they're bringing it together within their processing frameworks. And because of the fact that I mentioned a little while back, that there is heterogeneous hardware and software in there, any distributed computing system is only as strong as the weakest link. And therefore, with heterogeneity comes in greater amount of vulnerability. And the third factor, which is somewhat specific to big data system security, is that provenance of data is a very important concept. So provenance, tell me what you understand by provenance. And when you're answering, it would be good if you can turn on your video so I am not staring at a blank screen with 40 names in it. So what do you understand by provenance of data?
Sir, am I audible?
Yes.
Sir, does this mean that when the data becomes available, we should be able to prove that the data is authentic and has not been tampered with?
Exactly. So provenance is a part of what he said. Provenance just means where is the source of the data? Is the data coming from Times of India in Hindu, or is the data coming from some blog from an unknown person? And the level of trust that you may have in the data is going to vary depending upon the provenance of the data. So in big data frameworks, what is important factor is, can I track the provenance as I am going through this pipeline? So I know that Shomik has done some quite important work in this area. So provenance means initially I know that data is coming from sensor 1, sensor 2, and sensor 3. Individually, sensor 1 is quite trusted, sensors 2 and 3 are not very trusted. But as the data is moving through the analytics pipeline, these data is being mixed up. So how much trust can I put on the result that I get from the analytics pipeline? So that tracking the provenance is an important factor when it comes to security in big data computing systems. So let us look at a specific example now of Hadoop. Hadoop is a very, very widely used big data computing framework. And let me pause here and hear from you if any of you have used Hadoop in your projects, in your coursework, in your employment, internship, and so on.
Sir, can you repeat the question?
So I'm going to dig into the details of Hadoop as an example of a big data processing framework. And I'm wondering if any of you have used Hadoop in your work life or in your studies.
Yes, sir. It's actually a course in our IIT KGB itself.
Okay.
Offered in this semester, in fact, actually. It covers Spark, Hadoop, and and neural networks, and like more of a machine learning course using big data.
Okay. In which department?
It's a Department of Computer Science and Engineering.
Okay, and who teaches it?
Sir, this is Professor Shaurangshu Bhattacharya.
Okay, yeah, I know Shorangshu well. Okay, so for those of you who have not taken this course or are not taking the course, this is a very high level view of Hadoop. You have a set of map tasks and you have a set of reduce tasks. The map task takes the input data. In this example, it splits it by the key, and this is the value. K is the key, V is the value. So your key may be your roll number at IIT Kharagpur, and your value may be your name or your GPA. Then it sorts this by the map parts. They sort it by their keys. So you have a sorted list of the roll numbers and the corresponding values. And then it may merge using certain keys. So it may merge saying, give me all the roll numbers that are corresponding to computer science department, and then compute a function on the values. Maybe compute the average GPA and the standard deviation of the GPA for all the roll numbers that are corresponding to computer science department. And then it writes that output data in some Hadoop specific file system called HDFS. And one of the big breakthroughs of Hadoop and subsequent frameworks like SPARC is that they can run on COTS shared nothing servers. COTS stands for components off the shelf. So they can run on components off the shelf shared nothing servers. Means you don't have to go in and buy any special purpose server in order to run this. And you can just throw in a bunch of your Linux machines in a cluster, which don't share anything. They're just connected via a network switch, but they don't share any memory. They don't share any other resources. It's much easier to build scalable computing systems if you have shared nothing servers. So Hadoop runs on these shared nothing servers. So a little bit of the details of Hadoop is that you have a set of mapper tasks that read the job input data from the Hadoop file system. And then the outputs that they create are stored locally on the compute nodes. They don't go onto the file system. And the reducer now processes a particular key range. In our example, the key range they were processing were all computer science roll numbers at Kharagpur. And then ultimately, the outputs are written to HDFS. Now, how do we deal with failures in a Hadoop computing environment? So you have what's called a task tracker, which runs on the compute nodes, which is responsible for starting these mapper tasks, starting these reduced tasks, and this determines how much task concurrency is possible. Can I run 5 mapper tasks on one machine, or is the machine slow enough that I can only afford to run one at one time? And this task tracker communicates with a job tracker, which is the one which will decide when and where to start the tasks. So maybe a reduced task, well, almost definitely a reduced task has to wait till after the mapper task is finished and has generated the input corresponding to that reduced task. So there is a certain amount of synchronization that is involved between these tasks, and a job tracker tries to do that. A job tracker also has the job of improving the job completion time by speculatively starting up multiple replicated instances of a tracker, of a task. For example, if one of the tasks is determined to be slow, and how it is determined to be slow is where a lot of the sophisticated algorithms lie, then I can replicate this task and have it run in multiple copies of this task. So we also have to worry about failure cases, so non-responsiveness of a task. So the default setting is that the job tracker waits for non-responsive tasks. The task tracker sends a heartbeat to the job tracker every 3 seconds, and the job tracker will declare a task tracker dead if no heartbeat has been received for 600 seconds. Of course, you can change these default parameters depending upon the exact environment you are in. If you're in a fast network environment, you would set these to be smaller values. If you're in a very high processing capability computing environment, you would set this to a smaller value. And then the tasks are restarted on a different node once a failure has been determined. And a reducer is considered faulty. So remember, we have map and reduce if it fails too many times to copy the map output. And this decision is made at the task tracker. So these are some details through which Hadoop will handle unresponsive tasks, failed tasks. So here is an active learning activity for you. I want you to try this out. And Gunjan, if you can point them to the Moodle where this question is there. So this is a question that is related to Hadoop and how it will deal with failures. And you have to choose which of these answers is the correct one.
Yeah, so you can log into the Moodle and attempt the S7 item inside topic 1.
So let's pause for maybe 3 minutes and you can try that out. And Gunjan, once they have submitted the answer, will you be able to tell me what percentage got what answer?
Yes, sir. And I'll let
Very
you know.
good.
So currently
you can just post.
Okay. So total we have 23 plus participants. How much?
Okay. You can just post that on the chat to me.
Yes, sir.
When you
I'll
have
do
that tabulated. While this is going on, is there anybody who would want to share about, in terms of social network usage, what is the one security situation that you are most concerned about? Any particular security situation that concerns you? And then in my class next day on Friday, I can go over what has been done by social networks in order to address this kind of a security situation. Shashank, you're muted.
So I hope you can hear me.
Yes.
Yeah. So in while using social media, we are mostly concerned about our chats and the photos and videos we are sharing, uploading in our feed. We are that most concerned about that.
So what are you concerned about? What kind of security attack?
That someone for example, while using Instagram, we allow people to follow us, so we only want only that people can see our feed who are in our following list. No one else can try to catch that.
Got it. So you want to make sure that the access controls that you have set up are actually being enforced. And sometimes the access control policies are somewhat opaque, difficult to understand. So you may think you are giving access to this group of people, G1, but an overlapping but not identical group, G2, may actually get access to your social network post, social network content.
Yes. Yes.
Okay, let's take maybe another minute to see where you are with respect to this question.
Hello, am I audible, sir?
Yes.
So another major issue I think is with phishing attacks, because some of my friends have been a target of phishing attacks. Like they get links to some sort of websites where it seems like it's a legit website and they are logging into it, but it's actually a fake website and they use it to take control of their social media accounts. So
Exactly.
that is one of the very common attacks I've seen.
Yeah, so promoting one of my papers, I can tell you that one of the pieces of work that we did a few years back is on looking at phishing attacks by looking at actual mails that are received at a university campus. So we did a very detailed study of phishing attacks from the specific kinds of mails. The phishing campaigns that are sent to a university setting like ours are of course going to be different from the phishing attacks that are sent to a corporation or to executives at a corporation. So this work lays out a very large body of work which we did over multiple years, looking at phishing campaigns and how they evolve over time. And also we found that the phishing campaigns are quite topical in that if you have, let's say, right around the exams, then phishing attacks are on the grade submission system. When there is a big natural disaster which happens in one part of the country and people are raising money to support that people affected by that natural disaster, again, phishing attacks are customized to that. So anyway, this paper is a detailed look at phishing attacks that are available, that happen at a university. Okay, so 23 of 31 of you got the 0.999875, and that's in fact the correct answer. So the way to do this is, I will share my screen again. Can you now see my iPad screen?
Yes, sir, it is.
Okay. So now we have 3 Hadoop tasks, and each has the probability of 0.95 of finishing on time. So for any one particular task to not finish on time, I have this probability, and the probability that all 3 of them will not finish on time is this to the power of 3. And therefore, the probability that at least one of them will finish on time is simply this, and which comes to this 0.999875. Now, in doing this, I am making an important assumption. Can someone tell me what important assumption I'm making in here?
Independence.
Can you expand on that comment?
So we are assuming that the 3 tasks will be running independently. Like the failure of one task doesn't depend on the failure of the other task.
That's right. That's right. Okay. You were able to see my screen, but the broadcast did not happen. So let me try that again. Now you're able to see my writing in there?
Yes, sir, it's visible.
Okay, very good. So let's go on to the next slide. By the way, the slide material is also uploaded. Okay, so the next active learning activity is this one. So now I'm thinking about how much resource will my big data computing framework take? And the resource that we often worry about is memory, not as much hard disk storage, but memory. So let's say I have these 3 map tasks, again from the previous example, and each runs on 1 gigabyte of data. And I want this data to be in memory, not just sitting on storage, because it's so much faster. Now, these 3 map tasks have some commonality among them. So they're able to share 200 megabytes of data. So totally in this computing platform, let's say all 3 map tasks are running on the same computing platform. How much memory will I need for that? So that, Gunjan, this problem is also on Moodle, I presume, so
Yes,
you
sir.
can direct the people.
You can now attempt S8. inside topic 1, there is essay quiz which you can now take.
This is a simple one. Let's take another 30 seconds. All right, so we can close the Moodle and you can let me know, Gunjan. So this problem is, I think, a simple one. So here we have 3 map tasks and are you able to see my iPad screen again?
Yes, sir.
Okay. So here you have
Yes.
1 gigabyte of memory being used by each of them, but there is 200 megabytes which is shared. So the unique amount of memory per task is 800 megabytes. So the total amount of memory that would be needed is 800 megabytes times 3 for the 3 tasks plus 200 megabytes, which is 2.6 gigabytes. This is a calculation that is pretty widely done in computing systems where memory is often a precious resource. So what many computing software designs, system design tries to do is tries to increase the amount of shared libraries, shared usage, so that this total memory consumption of your computing system comes down. So the correct answer here is 2.6 gigabytes. Okay. All right, moving on.
So with 27 people voted for that.
Very good. So now, what are some of the security and privacy challenges in big data? I'm going to go relatively fast over this, so ask me to slow down with any explanations if you're lost. So infrastructure security is important. This is basically securing the hardware and the software. And within infrastructure security for big data, the big issue is how do I store the data? How do I secure the data store? And how do I secure the distributed programming frameworks like Hadoop? Data privacy is an important one, like you mentioned just a while back about social networks. You worry about the privacy of the content that you're uploading. So here, the big developments have been made in scalable privacy preserving data mining and analytics. Again, Shomik has done important work in there. Niloy has done important work in this field. Then you can have cryptographically enforced data-centric security. So here you are encrypting relevant parts of the data. And the big trade-off there is if I encrypt everything, it's hard for me to do deep analytics on that data. But if I don't encrypt anything, then I run the risk that I hear about regularly of data breaches. And then granular access control. So access control says who can access which resource, but at what granularity do I specify and enforce the access control? Do I specify it at the level of every database table? Do I specify it at the level of groups of tables or views? Or do I specify it at the level of individual rows, individual attributes within this table? So what is this granularity of the database control, of access control? In terms of data management, I want to have secure data storage and logs of all the transactions. I want to audit, again, at different levels of granularity. Do I audit at the level of every user? Do I audit at the level of every user for every window of time? And we discussed data provenance. How do I keep track of the provenance of the data? And in terms of data monitoring, I need to have endpoint input validation filtering, as well as real-time monitoring for security properties. So this is a very busy slide. This gives a nominal framework for a big data security framework. And this is from a Black Hat conference, which is one of the two top conferences where you talk about security vulnerabilities in existing production computing systems. So I won't go into the details of every block, but these layers are important. You have data management layer at the highest. Let's start from here. You have infrastructure security and integrity. This is very close to the hardware. You have network security. Here you talk about the security of data, both security and privacy of this. Here you talk about how do I give access to different users to different resources. And finally, you have the specialized data management blocks corresponding to the data analysis framework that you are using. Any questions or comments at this point? So I won't go over every single aspect of this, but point your attention to some. So in this case, in the data protection and privacy aspect, one thing that is quite widely used is data masking or data redaction before this ETL framework, ETL pipeline. ETL stands for extract, transform, and load. So this is a very typical processing pipeline that is applied in big data frameworks. And before you are doing while you are doing the data extraction, what you would want to do is de-identify certain personally identifiable information. So for example, your Aadhaar card number, you may want to de-identify, de-anonymize that before it goes into the transform part of your pipeline. In terms of network security, one important aspect to pay attention to is you are doing network security not just for data at rest, but because data is in motion. So if you have this framework and node 1 and node 2, let's say these are two different tasks in a Hadoop framework. And the data as it was being processed in here was encrypted before it was processed, and it's encrypted after it is encrypted before it was processed, which is decrypted during the processing. And here again, node 2, when it stores the data, it stores it in an encrypted format. So which is the window of vulnerability that we have in here? Anyone? So what does it mean for doing network security while data is in motion.
An eavesdropper could tap into the data via the network.
Yeah, and could you turn on your video when you're responding, please?
Yes, sir, sorry.
I hope, no problem. I hope this doesn't dissuade you from answering, but it's a lot more interactive if I can actually see the people who I'm talking to. Yeah, could you repeat your answer?
Yes, so like what I was saying is that the eavesdropper could actually access the data by tapping into the transmission line of the network.
So what would you do to defend against that?
We could even before transferring the data, we could actually encrypt it, and then we could decrypt it at the receiver node.
And what protocol is typically used for that?
Sir, it would depend upon the type of data and the form of data, but some typical protocols are AES, RSA, depending upon the need, obviously. If it's a symmetric encryption, then we can use AES. If it's asymmetric, then we would use RSA with a private.
Very good. So the protocols that are built on top of these specifically for network layer are called SSL and TLS.
SSL. Yes, sir. SSL
so
and
you
TLS.
can look into this. So this is the kind of protocol that would be used for protecting data while it is in motion being communicated from one to another. Okay, so here is another active learning activity. So I have data that is being processed through my big data computing framework, and my data has these 5 attributes. So which of these should I be anonymizing before I pull this into my big data computing framework? So this is really simple. Just check off the correct answer you think and take a minute.
You can attempt S14 on the Moodle page now.
So in some universities I've seen in India, the grades with the roll numbers are posted on the doors of the professor. Is that practice used in Kharagpur? How do you get to know your grades? Is it all electronically, or are there physical things which are electronically and secured, or are there physical things which are placed, or are there open places where your grades are also posted?
Sir, in online semester, we are checking our grades through ERP, which is a secure portal of KGP. So yes, only we can see it.
Okay, but in the normal semesters?
Sir, even in the normal semesters, we can see it on the ERP, but some professors they send like a mail to the whole class that with the names and the grades for all the students. But sir, there is also one problem with ERP that you can, if you know the date of birth of the student, you can check the grades for that student, date of birth and roll number. So that is a very big problem with ERP.
I see. Yeah, so the US, as you would imagine, is a very legalistic society. So we have very strong protections for privacy for grades as well. So there is a US law which is there for a long time now called FERPA, which is the one which protects the academic records of students. So it's to the point where, of course, for grades, they have to be highly secure, and you can never send an email out with the grades. to the class, even if it's just the ID. And in the classroom also, you can't just say, here's a stack of papers, you come and take the papers, your paper. So you have to be careful because there are fines, big fines, which are associated with violations of FERPA. And to the point where a student comes to me and says, right, could you write me a recommendation letter? I'm applying for a PhD in this school. So I cannot just say the student got a grade of A in my class when he took it in his third year of undergraduate. I cannot say that. I have to get a written authorization from the student to say it is okay for me to release his grade in this letter, so that I'm not violating this FERPA law. So the correct answer in this case turns out to be the grades, the FERPA. So now this is somewhat US specific, but that is considered to be the protected information. And home address is surprisingly not, but a student has the option of saying in his academic records that, okay, this should also be a protected field. Okay, so moving on. One big debate that comes in terms of security of big data frameworks is, should we have centralization versus decentralization? So centralization oftentimes is useful for efficient data analytics, efficient data processing, but it is not very useful with respect to security, because now you have put what they call, the saying is putting all your eggs in one basket. You have put all your eggs in one basket, and if the security for that one centralized data store gets violated, or that centralized computing framework gets violated. So let's say somebody is able to tap into your SPARC processing framework and is able to see the data as it is being processed, then the security goes out the door. Another form of security is sometimes there are regulations, laws, which mandate that your analytics processing has to happen within geographical boundaries. So here I'm giving you an example of a real law which exists today in one part of the world, and I want you to fill out the blank that is in there. You can just blurt out what you think is the answer. Here it's saying that this is restricting where the processing of the data needs to happen. So the data is sitting in, let's say, country A. While this data is being processed, you can't say, let me ship the data to country B, and then once the processing is done, I can ship it back to country A. These laws regulate within which national boundaries the data can sit. So anybody has an idea which regulation this is and which country we are talking about here?
So in India, there was this law released for payment systems.
Yeah, exactly right. So this is a notification from RBI issued in 2018, and the blank here is India. So it mandates that all the data relating to payment systems has to be stored in a system only in India. So when you use Google Docs or any of the Google processing frameworks, if you're going to use it for financial data like this, then you have to have a special contract with Google to make sure that they're running only in data centers which are there in India. So the challenge that this poses is, I want to extract the knowledge from the data while keeping the data distributed, but at the same time, I have to respect laws and regulations like this, which enforce that they have to be within particular national boundaries. So here is a checklist which people use for security pre-processing when you're using big data frameworks. So one is you locate and identify where all the sources are, where all the data is sitting and who has access to them. You classify the data according to the sensitivity and the business criticality. This is, of course, not a scientific form, but this comes out of a lot of practice. So when you go to work and you're working on some system which has critical data, you will find some version of a checklist like this that you have to use. This one specifically is generated from a company, a large company that I work with. And you have to develop and keep continuously updated policies regarding data handling. So what kind of data must be stored for how long, where all they should be stored with, and which kinds of users will have access control. You want to create security controls to enforce that these data access control policies are in fact in effect. And these access control policies must be monitored and changed as the roles or users change. So let's say an employee leaves the company, or an employee moves from unit 1 to unit 2, or an employee stays within the company but goes from country A to country B. The access control policies will have to be monitored and enforced as that goes on. So one product category that is widely used is called SIEMs, Security Information and Event Management. So this is a product category that many of the big security vendors have, and you use this in order to run through this kind of a checklist. So here is another active learning activity. So this was done by surveying security practitioners at various IT companies. And can you rank order these following uses of big data in order to gain a security advantage? So we've been talking about some of the security vulnerabilities that are introduced by big data frameworks. Can you think about what are some security gains that you would have from using big data? So rank order these. And let's take a minute, and then we'll break for a few minutes.
You can attempt the quiz Active Learning S19 rank. If it asks for a password, it's ABCD 1234.
Hardly anybody gets the complete order right here. Okay, so we can stop now, and let's take a break. It's 10:01 a.m. here. So let's take a break for 7 minutes and we'll come back at 10:08 and we'll continue. Any questions? All right, so we have a break for 7 minutes. All right, I'm back. Let's go on now to the next part. So what we have done, can you hear me still, Gunjan?
Yes, sir. Yes, sir.
Yes, sir.
So what we have done so far is we've covered some of the basics of security protocols, security factors in big data. And now we are going to look at some state-of-the-art attacks and defenses in big data systems. Gunjan, are you able to see the beginning slide which says Lecture 5 Security in Big Data?
Yes, sir. It's
Yes,
visible.
sir.
Okay. So here we are going to talk about a topic which has become very, very hot in the last 4 or 5 years, and it has continued to stay really hot. It's called adversarial machine learning. You have papers at adversarial machine learning appear at the top security conferences, at the top machine learning conferences, huge amounts of funding, huge amounts of work being done by the top companies, as well as lots of startup companies in this space. So what is all this craze about adversarial machine learning? So this is so far it has been like a cat and mouse game of security attacks against various machine learning algorithms and defenses that are designed against these attacks. So here are examples of adversarial examples where if you look at these images, these are actual images which have been created in order to fool state-of-the-art machine learning algorithms. And if you look at them, you will say there is no way this is a penguin. There is no way this is a starfish. But by creating carefully manipulated noise into these images, it can fool the state of the practice algorithms in concluding that this is a penguin and this is a starfish and this is a baseball. So adversarial machine learning at a really high level deals with this, is what are the different ways in which the data or the algorithms can be manipulated in order to give a wrong answer, and the defenses are trying to thwart that. So if you look at this picture, then most of you will be able to say that this is a panda, but now a small adversarial noise is inserted into this image, and then your object classification algorithm misclassifies this as a gibbon. So that may be fine because just by looking at it, you can say, yeah, this is not a gibbon. But now think of the promise that we have of autonomous transportation, autonomous vehicles. They're already there at various different levels. So the Society of Automotive Engineers in the US describes 5 different levels of autonomy. And level 5 is the one where you can be lying in your car and sleeping, watching TV without your hands on the steering wheel, without paying any attention to what is going on in the road, and your vehicle is doing everything for you. So I think India would be the last place where autonomous vehicles would become a reality because of the challenges on the road. But there has been a lot of talk of doing that in limited places in the US, and there already are vehicles which are moving there. So an autonomous vehicle, what it has to do very well is it has to understand road signs. So this is a road sign which says stop. It means exactly what it says. Every vehicle is supposed to come to a complete stop when it sees this sign, and then after making sure it's safe, then start moving. So again, now you introduce a small adversarial noise, and this, while it looks like complete random noise, is in fact not random. This has been generated by an attacking algorithm to very specifically fool the particular algorithm that it's targeting. So now as a result, it becomes an yield sign, or if the attacker is really creative, then it becomes something which is completely confusing, and your self-driving car, your autonomous car, now is completely fooled and is not able to make any progress. So is that all there is to adversarial machine learning? The answer is no. Adversarial machine learning has turned out to be a weak spot of machine learning, and it has hindered the widespread adoption of machine learning systems in critical computing environments. So if your machine learning system is just meant to predict which is the next song that you want to listen to on social media, who cares if it gets it a little bit wrong? If it's supposed to predict which is your favorite game, online game that you want to try out next, who cares if it gets it a little bit wrong? But as it starts to get used in more critical computing systems, then you do care about incorrect decisions being made by your machine learning system. So it's used for fraud detection. So anytime you use your credit card, for example, anytime you make a bank withdrawal or deposit, there is a fraud detection system which is working under the covers. You want that to work fairly well. Malware detection, intrusion detection, spam detection. So all of them have in common is they want to detect bad things. So bad actions, bad actors, bad objects. And what would happen is with adversarial machine learning, you can thwart, you can bypass the defenses that happen in here. So one of the key issues in adversarial machine learning is the bad actors, the attackers, have objectives. And one of the key objectives is not to get detected, because the adversary is not interested in doing just a one-shot attack, but is interested in doing an attack for over many months, over a long period of time, so that it can amplify the effect of the attack. And therefore not getting detected is an important part of the goal. So they can change their behavior in order to avoid detection. And that's where this concept of evasion attacks comes in. So the malicious object is deliberately transformed so that it achieves its objective. So if its objective is to skim money away from your bank account by sending some spurious kinds of transactions, it achieves that objective. But these spurious transactions are designed in such a way that they can evade detection by the machine learning systems. So you may think that let's just keep the algorithm of my machine learning system secret, and that way the bad guys would not be able to craft malicious attacks which would be able to evade my machine learning system. So this is a term which is used in the security literature. Does anybody know what this principle is called? Let's just keep my algorithm secret, and that should give me protection.
Security by obfuscation, I think.
Anybody else? So that's exactly the term that's used, security by obfuscation. And it is now widely known in the security literature that this does not work. So the most popular, the widespread crypto protocols, their algorithms are all known. Your AES, your RSA, all algorithms are known and have been known forever. But it's the secret key that is not known. So do not try to do security by obfuscation of your algorithm. Rather use a small, very small piece, 1024 bits, the key, which will be used to generate guarantee the security of your system. So a different class of attacks is called data poisoning attacks. So what data poisoning attacks do is that they insert instances of data which have been carefully modified. Like we saw in the earlier example with image data, they have been carefully modified so as to fool your object classification algorithm. Now, You could modify certain instances of the data. For example, you hack into the server that is used to store the data, or you could selectively remove some instances of the data. And you could do this either at the training stage, or you could do this at the production or test stage. So this could be done at so you should now be seeing my iPad screen and me writing there. So data poisoning attacks can happen either when you are training your algorithm or at test phase. So training is you modify the data that is being your model is being trained on.
Sir, the text is not visible, like whatever you are
Right, I
writing is not.
realized that. Okay, so now it should be visible. Data poisoning attacks can be done at training phase or at test phase. So at test phase, let's say the sensor that is gathering the data, you hack into that sensor, so it sends you incorrect data. And data poisoning attacks at another level are characterized by how many sources of data are being poisoned. So is it just the data sitting on one node? Is it just the data coming from a single sensor? Or is the data coming from K of these end nodes, K of these end sensors? Any questions at this point? So the crucial distinction between these two classes of attacks is that the evasion attack is an attack on the model that has been learned, and the data poisoning attack is changing the data so as to beat the algorithm that has been done, beat the algorithm. So the model that is being learned itself will become a faulty model if the data poisoning attack happens at the training time. Evasion means that your model is done, your model is secure, your model is as good as the designer of the model wanted it to be, but the data is created so as to bypass that learned model. So adversarial examples in a DNN setting are close to what are called these evasion attacks, because they are not changing the DNN there, but for a given DNN, they're able to come up with certain examples that are going to bypass the DNN. So instead of a stop sign, it becomes an yield sign. Instead of 70 kilometers per hour speed sign, it becomes 110 kilometers per hour speed sign. So adversarial evasion, how does this happen? So in modeling these kinds of attacks, there are two classes of attacks that you talk about. One is called black box attack, the other is called white box attack. Black box attack simply means that the model that you are trying to attack, that is a black box to you, you being the adversary here. You don't know the internals of the model. So you may think that if I keep the internals of my model hidden, like how many layers in my neural network, what are the initialization conditions for my neural network, that will make my model secure. Unfortunately, it turns out that that kind of hiding does not make your model secure, because the adversary, by sending queries to the model, can create a proxy model which is quite a close representation, close approximation of the original model. So what originally the designer thought would be a black box model quickly becomes transparent to the adversary. White box attack obviously is the other part of it, is the other kind, where the details of the model are released to everybody, including the adversary. And the white box attacks are the ones that if you come up with a new protocol today, you'll have to make sure that your work is secure against white box attacks. So here is very basics of classification. Everybody here likely knows this. So you have two classes of objects, the blue class and the red class, and you have a classifier, which in this case perfectly divides this data into two classes. So you have a set of feature vectors, x's, and binary labels, which is -1 or +1. So maybe your feature vector are those images that you post on Instagram, and your binary label is this person happy or sad? So you train your classifier in order to learn based on the training data. And now if you feed it new kinds of images, and this is what popular social networks do, they will try to figure out if the person there is happy or sad or neutral. So now what can happen with classifiers is they are often meant for telling good from bad. Is this spam email or non-spam email, often called ham? Is this benign software or malicious software? Is this transaction on my bank account a legitimate one, or is this malicious? So somebody mentioned phishing attacks earlier. So this is an example of a phishing email. Now the classifier is trying to tell the classifier that runs under the covers of my mail client is trying to tell if a mail that I received is a phishing email or if it's a benign email. So the adversary previously chose instance X, which is now classified as malicious. So he knows that my model, my phishing detection model, is able to classify this instance X as malicious. So he wants to evade this. So what does he do? Is he goes from X to X prime such that X prime is now classified as benign by the model. But X prime still does its bad thing. X prime still has a link to a malicious website, which if I click, I'm going to go in there and I'm going to release my secure credentials, my secret information in there. So X to X prime. So here is the mathematical formulation behind it. This X prime now causes the data point, it's to go from the malicious side to the benign side, and as a result, it does not get flagged. So let me pause here and ask, in your daily usage, the mail clients that you use, I'm sure they have this kind of facility where they would classify incoming mails. How often do you think it makes mistakes in either direction, either classifying a legitimate email as malicious or a malicious email as legitimate? And what fraction, what proportion do you think your mail clients do?
Sir, in my experience, the current, like the Gmail, let's say talk about Gmail. The Gmail spam detection is like quite good in classifying the spams, but I think it has like more false positives than there are false negatives.
If you had to put a percentage number, what would you put?
I think 80 to 90% of the time it works fine.
In terms of what proportion are false positives, what proportion are false negatives you get?
Maybe the 10, let's say 10 to 20% of the like the wrongly classified cases, I would say around 6% they might be false positives, and the rest are false negatives.
Okay. Anybody else have an opinion on this? So let's take a look at an example of an evasion attack. Gunjan, can you hear me still?
Sir, yes, sir, you're audible.
Okay. So let's take a look at an example of an evasion attack. So if the mail has these words, let's say cheap and mortgage. Mortgage is something that you don't have to worry about till later on in adult life. But when you own a house, then you have to worry about mortgage. And this is a common kind of a phishing email where they promise you that you can get a cheaper mortgage. And many people may jump at this because mortgage is a big expense. So if you see the words cheap and mortgage, maybe you have a really simple classifier which assigns feature weights to these words. And a higher weight means it's more likely to be phishing or spam. So if the threshold is 1.0, then you add up the weights of these words and you get 2.5 and you classify this as spam. So now if I want to do an evasion attack, I being the bad guy, want to do an evasion attack, what I do is I add some words which I think would resonate with the people who of my target audience. So if my target audience is students and faculty at Purdue, then I may add these words Purdue and Indiana. Do you know what the relevance of the word Indiana to Purdue is?
Location.
Is it the city? Is it the state? Is it the country?
State.
So it's one of the 50 states in the US and it's the state where Purdue University is located. So in order to gain resonance with the people that I'm targeting, I put these words in there. Or if I'm now talking about IIT Kharagpur, then I put these words IIT JEE and tech market in there. And let's say that these have negative weights. Negative means it's more likely to be benign. And therefore the total score comes down and it's below the threshold, so it goes through my phishing or spam filter. So this is an example of an evasion, a really trivial example of an evasion attack. It relies on the adversary knowing what the threshold is and what the algorithm is for assigning these weights to different terms. And as I mentioned, even if you keep your algorithm hidden, by sending enough number of queries, the adversary can usually figure this out. So this is how we model evasion attacks. So I'm now sharing my iPad screen. So from an adversary standpoint, you have an ideal adversarial example. And by ideal adversarial example, what I mean is it causes the greatest amount of damage. But if I pass this adversarial example through my security technique, then this is going to flag it. So what the adversary does is it does a transformation from X ideal to X deceptive, such that my security technique, when it works on X deceptive, does not flag. But now one optimization that the adversary has to solve is some cost function, which is a function of the difference I want to minimize or maximize this, I being the adversary. What would I want for this cost function, low or high?
Lower.
I want this to be as low as possible. So this cost could be in terms of how effective X deceptive is relative to X ideal, or cost Okay, so this is the optimization function that the adversary has to solve in order to launch the evasion attack. So now, in terms of one dimension in which attacks are characterized are how much knowledge does the adversary have. So the black box attack means that adversary does not have knowledge of the model and can only send queries to the model. And it has been found that black box attacks quickly devolve into the case where the models you can get to know about it, with one exception where if the model is being randomized. So you're not always using the same seeds, you're not always using the same weights, then randomization can help in keeping your black box method really black box. Gray box means that the attacker knows some details about the data set. For example, what kind of neural network are you using? What is the structure of the neural network? What is the width? What is the depth? And in a white box method, the adversary is assumed to know everything, including what are the weights of every single edge that you have in there. What was the data with which the network was trained? So today's state of the art, if you want to get published at a top security or a top machine learning conference, you have to make sure that your defense is able to withstand a white box method. So maybe your defense is so strong that in order to bypass the defense, the adversary will have to make such a big change that the attack will become toothless. So that's the goal of your defense mechanism. So how much change does the adversary have to make in from X ideal to the X deceptive? So this is typically measured by using a metric called LP norm. So the LP norm of a vector is defined like this. So this is the P is the parameter in here. So the L0 norm is simply the number of non-zero elements that you will have in the vector. So if you have a vector 2, -3, and 4, the L0 norm of that vector is going to be 3 because you have 3 non-zero elements in the vector. L1 norm is the absolute value of all elements, each element in the vector, and summed up. So this is going to be 2 + 3 + 4, or 9. L2 norm is going to be the square root of the sum of the squares. So L2 is going to be, so if your vector is 2, -3, and 4, the L2 norm of this vector will be and the L infinity norm is simply the max value of the max absolute value. So the L infinity norm of this is going to be 4. And the L infinity norm of this vector 2, -3, -10 is going to be what? Say that again.
It will be 10.
10. So now this cost function that I mentioned. So now this is the most powerful attack against neural networks called the Carlini-Wagner attack. So it uses the L2 attack algorithm to generate adversarial examples. So again, today's top papers at the top conferences have to show that they are resilient to Carlini-Wagner L2 attack. So what the adversary does is the adversary tries to minimize this whole function, which is the sum of two terms. So it tries to minimize the L2 norm difference between the legitimate example and the malicious example that the adversary is creating. So I try to come up with the X prime that is going to minimize this function. So it's argmax X prime, argmin of X prime. So I try to minimize the distance between the legitimate and this X prime malicious example, and I try to minimize this cost function with a coefficient C. L is the loss function. So So this loss function is going to be high if the adversarial example is unlikely to induce a misclassification. Remember, I want to push the data point from one class to an incorrect class. If it was a legitimate one, I want to push it to malicious so that I have a false positive. If it was originally malicious, I want to push it to negative, push it to benign so that there is a false negative. So this first term constrains that the malicious example is not too different from the original benign example. So is this math making sense? Any comment or question?
Sir, why this math actually? Since if we want our neural network to make a wrong classification, then we kind of need to, we are trying to fool the features that it has learned in its internal layers, right? So is it somehow related to that?
Yeah, so it is related to that, but there is this additional constraint that it puts. So what you just said is related to this. I want to increase the
Yes, sir.
I as an adversary want to make it such that there is a misclassification with a high likelihood. But okay, I want to. So the loss is if the adversarial example is unlikely to induce a misclassification. So if it is more, so if it is unlikely, then this loss value will be high. So I want this value to be as low as possible. In other words, I want my adversarial example to induce a misclassification. But at the same time, I don't want this adversarial example to be too different from a legitimate example. Why? Because let's say my legitimate example has all values between 0 and 255 of every pixel, 0 and 255. If the adversarial example is now 500, then it's very easy to filter out this adversarial example by simple rule-based methods. And that's why I impose this other constraint that the two shouldn't be too different.
To remain deceptive.
To remain deceptive, exactly. Exactly. Any other question? Okay, so here is an active learning activity for you. Take 2 minutes to think through this and give me, there's only one correct answer out of these 4 choices. So give me what that'll be.
You can now attempt S31 item in topic 1.
Is there anyone who is not able to access the slide material for today's lecture? It is posted on Teams. Okay, good. So you can go back and look at earlier slides. Okay, so let's take maybe another 15 seconds. Okay. So Gunjan can tell me down the road what you got for this. The correct answer for this one is, so let's see, if we set C to be a high value, then I am placing a very high premium on the adversarial example actually causing the misclassification. I am not paying as much attention to the deceptive nature of my adversarial example. So then the adversarial example will become far from the benign example. So that would be the correct answer for that part. Okay.
7 people got that right.
7 out of 32.
25.
35.
25. 20.
25. Okay. Okay. So now think about data poisoning attack. So data poisoning attack is an important class of attacks against these big data machine learning systems. So with data poisoning attack, what the adversary can do is can insert instances, specially crafted emails, either benign or malicious, can modify instances which already exist in the data and can selectively remove some instances from the data. So this we just covered a little while back. So now let's think about one poisoning attack against support vector machine, SVM. So here the attacker knows the learning algorithm and the attacker can draw the data from the underlying distribution. So if the underlying distribution is, let's say, normal with a mean of 10 and a standard deviation of 1, the adversary knows this and can therefore flip coins and can generate data from this underlying distribution. And now the adversary can inject some additional spurious data points into the training data, which will be used to create the model. So the attack technique here relies on the adversary very deliberately injecting certain data points so as to be able to manipulate the optimal SVM solution. And this attack point generation can be formulated as an optimization problem. So the adversary is not dumb. The adversary knows how to solve optimization problems, as we just talked about a little while back. So here the adversary is solving an optimization problem with respect to hinge loss on the validation data set. So from your basics of machine learning, you know that if you think about the data, you can think about it in 3 terms. You have your data set, you can think in terms of so you have the training data. These are both available to you at the time of training the model. And this is the one which is available to you only after your system has been deployed. So you have the training data as well as the validation data. The training data is the one that you use to create the model. The validation data is the one that you use to verify if your model has converged or not. And then this test data is what your customer gives you once your system is in operation. So at that time, you cannot easily go in and modify your model. So in this context, so here the adversary is optimizing based on the validation data, which the adversary has access to. And this technique works even though this optimization problem is in a non-convex space. So from your basic optimization class, you would know that if your function is convex, then it is easy to do an optimization. You can maximize it or minimize the function using very well-known algorithms and well-known tools. If on the other hand, your function is in a non-convex space, then doing the optimization is harder. So as we'll see in a minute, this is in a non-convex space and still the adversary can create this. So this is a typical loss function that is used in classification tasks in machine learning. This is called the cross entropy loss, oftentimes shortened as CEL, also called log loss. So what this does is it penalizes, if it's, let's say, a simple binary classification, it penalizes if your original 0 label is misclassified as 1. It also penalizes it if your 1 label is misclassified as a 0. Now, one challenge with this cross entropy loss is that if you look at this figure, the cross entropy loss is this yellow curve. So this cross entropy loss is not differentiable. It's not a continuous function. So it looks like this. So you know from your basic calculus that this is not a differentiable function because it is discontinuous at this point. So what we do instead is we use a proxy for this cross entropy loss, which is called hinge loss. So this hinge loss looks like this. It does a max of 0 and 1 minus yz prime. So I'm not going into the details now, but you can think that if your data sample is correctly classified, then this product is going to be positive. And if it is incorrectly classified, then this product is going to be negative. And the more incorrect it is, the farther off the points are from the boundary, the worse the misclassification is, and it becomes more and more negative. So if you have a misclassification, then in this term, which term will win out? Will it be the 0 or will it be the second term that will win out if you have a misclassification? Let me call on somebody who I have not heard from yet, unless there is a volunteer. So my question is, if you have a misclassification, then which term will dominate? The 0 term or the second term?
So if there is a misclassification, then 1 minus yz hat will dominate.
The 1 minus yz hat will dominate, and the worse the misclassification is, the more positive this value is going to become. And I want this loss function to keep increasing as I make worse and worse mistakes. So that has the necessary thing. And at the same time, this is a continuous function. So this is considered to be a good proxy for the actual cross entropy loss. So it penalizes the wrong predictions, but it also penalizes the right predictions if it is right next to the classification boundary. So it has both of these factors, and it is convex while misclassification loss is non-convex. So here is the final active learning activity that we're going to do today. So what I have here is a binary classification that I'm trying to do. My actual labels are yi and my predicted labels are yi hat. And it's binary classification, so it can be either plus or minus 1. So how will I define the loss function for misclassification? So I have defined part of it for you. It will be 1 in this case, it will be 0 in this case. But what you have to fill in are the values of A and B. So what would be a correct way of defining the misclassification loss. So take 2 minutes to work on this. And while you're working on this, let me ask a fun curiosity question. Many of you, maybe all of you, are doing this class away from Kharagpur, sitting at your homes. Who among you is the farthest away in terms of geographical distance from Kharagpur? Myself excluded. You won't know for sure, but go ahead and blurt out where you are, how many miles away from Kharagpur you are.
Sir, maybe me because I'm in Jammu and Kashmir, because I'm in Udhampur, Jammu and Kashmir. So.
Okay. Which is how far from Kharagpur?
So just let me check. I think it's around 2000.
Okay. So I'm about 8,000 miles from Kolkata, and Kharagpur is close enough. In fact, I remember from my days in Kharagpur, it is 116 kilometers from Kolkata. So that's why I excluded myself. Anybody outside of the country? Anybody beat Dhruv in terms of how far you are from Kharagpur? So nobody farther than Jammu and Kashmir? Who is the second farthest away then? I know it is late in the evening for you, but surely you are still awake. Who's farthest down south in India?
Sir, I'm from Hyderabad. Maybe I would be the second farthest.
Okay.
Other than other than North Indian. Sir, I'm from Hyderabad, sir, which is some 1,300 kilometers from Kharagpur. So
okay, yeah.
Maybe I would be the second person who would be the more farthest South Indian.
Okay,
yeah.
That's good to know. Okay, so the correct answer for this, let's see, anybody, any volunteers? So let's think about this. If yi is 1 and yi hat is 1, that's a correct classification. So then the product of yi and yi hat is +1. If on the other hand yi is -1, then the correct classification is yi hat is also -1. So then also the yi and yi hat product is going to be +1. So +1 means there is no misclassification, and -1 means there is misclassification. Therefore, I want to set that the loss value should be 0 when there is correct classification. And as we just discussed, our correct classification happens when yi times yi hat is equal to 1. And my incorrect classification happens when yi times yi hat is equal to -1. And therefore, the correct answer for this is going to be A is -1 and B is equal to 1. Any questions?
13 people have responded. Is correctly out of 25.
Okay. So for anybody who did not get it right, do you have a question? Can I explain this? Okay, so we have reached the end of our time. I had more material, but since we were having a lot of fun discussing with you, I did not cover all of the material in here today. So I will finish up the rest of this lecture on Friday, and then I'm going to go into, as I just promised earlier, into some attacks and defenses against online social networks today.
Sir?
Yes?
So is there any popular example of white hat attack ever happening before? Like from what I can see that mostly these security principles, like how security mechanisms are constructed, they don't publicly disclose their like weights and biases and measures. So
yeah,
how will a attacker carry out a white hat attack?
So the attacker carries out a white box attack by sending repeated queries to the model and by figuring out a proxy for the model. And that's why in the research literature today, if you want to claim that your defense is good in machine learning, you have to show that it is resilient to a white box attack. So you're right that Google does not go in and disclose what is the model that it uses for classifying spam in Gmail. However, Gmail is an open platform, is a sort of anybody can use it. So you can send hundreds and thousands and tens of thousands of, you as a bad guy can send such mails and try to get a proxy for the model. And then you attack that proxy. So that's why the white box attacks are feasible.
But then even if I send several requests, it's not guaranteed that it is very difficult for me to get all the information related to the model. So in that case, won't it be mostly gray box attack?
Yes, you can say that. You can say that. However, you in security, you try to design for the worst case, and that's why you try to design your system for the worst case, and therefore the white box attack. The other way white box attack happens is through simple human means. Somebody gets fired from that company, he is really ticked off, he goes in, he walks out the door with the code and with the model details. And with any large company, you are always going to have disgruntled employees, and they will just release that code, release that model out in the public. Good questions. Any final question? Okay, then I have a request for you. I'm going to send a link to a survey, a quick one, that you can fill in, indicating what part worked well and what part did not work well in this lecture. So at the next one, I can moderate, change things accordingly. So I just sent a Google form in there. So please go in and you can provide this anonymously, of course, but provide any feedback you have from today's lecture. And please do this while it's still fresh. Don't wait for tomorrow. I'm going to take a look at it and make any modifications that I see are needed based on the feedback. Okay, we are 3 minutes after our time, so we'll call it quits for today and resume on Friday.
Thank you, sir.
Okay, bye-bye.
Bye.
Thank you, sir.
Good night.
So Shomik, if you can stay on, are you still around?
I think that Shamik sir has left. He is not.
Okay.
He said he had some other meeting. So.
Okay, I'll follow up with him outside of this then. Thank you, Gunjan. You've been a great help. I gave you a lot of work toward the last minute. If you can just show your video so I know who I'm talking with, but you've been a great help in running the class.
Laptop doesn't have a camera right now. Like it does not built in camera.
I see. Yeah. So I think the Moodle is working fine.
Yeah. Like the main motive here was that since it's not that graded thing, so I'm just putting up pop quizzes where they can just vote and then I can collect the final counts, like who responded what in that sense.
And do you have to manually count or it's auto?
No, it's there. It's like it's just like taking a poll, like which option do you think is correct? So
yes,
it went well.
That's good. You are working with Niloy?
Yes, sir. I'm a PhD student under Professor Ganguly.
Okay. How many years into your PhD?
This is my first year. No, yeah, this is my first year, like towards the end of the first year.
Okay. Okay. So are you going to go to Germany or
No,
are you going to stay
I
at
am in
Kharagpur?
Germany. I'm in Germany currently.
Oh, you're in Germany. I see. I see.
Yes, sir.
Okay. So how is your German?
Not that good. Like I'm just here for a 6 months contract, so I'm not bothering on
Did you
that.
have to take any class when you went to Germany? German
No, no, no,
class?
no.
Okay.
Like it's an internship opportunity, so they don't like ask for that. But if I would have come for masters or for higher education, then class would have been necessary as per the
Yeah.
visa guidelines.
So which city is this in?
Hanover.
Hanover. Okay. Okay.
So the L3S research group, I'm working with them. I'm
Which
interning there.
research group?
L3S under Leibniz
L3.
University.
I see. And you'll be there till when?
Till February 2022.
Okay. That's a nice opportunity for you at the beginning of your PhD.
Yes, sir. Yes.
And then the expectation is Niloy is going to come back.
No, NG sir actually is working in a collaboration here. Like they're here running a project called Future for AI Labs. So they're collaborating with like 8 countries, and with India, Professor NG is the one representing there. So I think he will stay for like more than 2 or 3 years.
I see.
More than 3 years.
I see. And he's your only advisor.
No, I'm being jointly supervised with Professor Ganguly and Professor like Dr. Mainak Mandal. He is also in CSE.
Okay.
Yeah.
I have not interacted with Moinak. Let's see.
Like my master's was under Professor NG only, but when I switched to PhD, so Professor NG and Mainak Mandal, like joint supervision.
Okay. Okay. And you did a project masters, which has a research component to it?
Yes, sir. Yes, it was like one year of courses and 1 year of research.
Okay. And then most people take the course-based masters.
Yeah, in India, actually, there are like two paradigms. One is MS and one is MTech. So I got in IIT Kharagpur through the MTech course. So there we have to like do credits. And for the first year, we take credits, and for the second year, we normally do the coursework. So I was in the MTech program.
And is there a research-based masters as well?
Yeah, the MS, Master of Science, like that is another code. So that is a 3 years course, and in there it's like more research and less focus towards the credits. Like, that is the normal arrangement.
So do most people come in the MTech category?
Yeah, like